Hey, thank you everybody for joining us today. Hopefully you've had a good first day here at our Advancing AI event. We've got a lot more to come, both a little bit more today and a lot more tomorrow. So I hope everybody is taking full advantage of it. Let me do a couple quick introductions. My name is Matt Unangst. I'm with AMD. I lead our enterprise solutions team at AMD. I'm based in Austin, Texas. I've been with AMD for about 19 years. I'm joined today by, go ahead.
Hey everybody. My name is Scott Tees. I'm brand new to AMD. So if you take Matt's time and tenure and mine and you average them together, it's 10 years because I just started about 6 weeks ago. But I run our high performance computing and our sovereign AI globally. So looking forward to the conversation today. Thanks for being here.
Test. There we go. Afternoon, everyone. I'm Ryan. I'm with Rancher Government, and we are a secure and open by design Kubernetes platform serving the U.S. government and allied partners. We'll be talking about how that is a core enablement layer for a lot of AI workloads that are operating in both public sector use cases as well as critical infrastructure. So thanks for the time.
Awesome. Thanks, Ryan. So what we're going to do over the next few minutes here is I'm going to take a little bit of time to talk about our approach and our strategy around enterprise AI deployments. And then we'll talk about how that same approach and some of those foundational capabilities and hardware that we have are pertinent and leverage heavily into how we approach sovereign solutions. And of course, Ryan will cover his piece and talk about how our partnership and the engagement there works. So we're hoping we have a little bit of extra time and have some Q&A at the end. Certainly welcome and encourage interactive conversation here. This is obviously not news to anybody in this room, right? But AI is literally everywhere, and it's growing at such an incredibly fast pace right now. We think about AI technology, it has infiltrated our entire economy, the way we work, the way we live, from the data center to the devices in our pockets across so many industries. You think about retail, you think about automotive, aerospace, healthcare, telecommunications, financial services. In every corner of our economy, AI technologies are beginning to transform the way that we're doing our jobs and getting our work. You know, if you think about some of the examples, just to provide a few targeted spaces, right? In healthcare, AI is evaluating medical imaging that's allowing doctors to flag, identify, and more rapidly and effectively treat illness and disease. You know, you walk around the streets here and you see autonomous cars. It's pervasive, right? That technology is, you don't even think about it anymore. And then if you think about the worlds of science and research and development, from areas such as protein folding to material science to how an automotive manufacturer designs and simulates an entire vehicle before ever actually building a physical prototype. This technology is enabling us to take what used to take years and do it now in months. It's fundamentally transforming the way that we use technology, the way we do our jobs, and the way we bring new products and capabilities to market. And what's incredible is that we are really, truly still at the beginning stages of this entire process. I have the good fortune to be able to go talk to a lot of customers and partners across the ecosystem. And what we see by and large is that most organizations are just now starting to really figure out how to utilize this technology, which means there's just so much more potential in front of us. So part of what we want to talk about here today is how do we deliver a more scalable, more turnkey set of solutions for AI across the enterprise and sovereign, because the more that we can collectively deliver a turnkey solution across the hardware, the orchestration layer, and the application layer, working as an ecosystem and with a bunch of partners, the faster we can help our customers achieve what they need. Let's take just a second and talk about what is driving compute and what that compute demand looks like right now. This wave of AI is creating demand for compute that is really unprecedented. I think we all see it, we all feel it. We know the pressures that ourselves and our customers are dealing with right now in terms of trying to procure hardware. If you think about just a couple of years ago when the focus around AI was all around training, while the process of training is incredibly complex, the hardware needs, I'll say relatively, were pretty straightforward. You needed heavy-hitting GPUs. It was a very kind of understood set of capabilities from a hardware perspective. That demand for that type of use case has grown incredibly. It's what's driven a lot of the AI economy over the last couple of years, and it will continue to grow. But then you look at the onset and the deployment and the use of inference, and that has fundamentally shifted the type of hardware, the flexibility of the hardware, the form factors, and the use cases around AI. And it's driven a new cycle of demand for compute around AI. Yes, we've optimized models, but when it's all said and done, there's still a need for a lot more compute and across different form factors and different, both in the cloud and on the edge. The key now, though, is that we are in the agentic era. And this fundamentally shifts the need for compute in a way that we have not really comprehended up to this point. It's not just about providing a prompt and getting a response at this point. It's not just about horsepower of GPUs. It's now about the ability to go actually execute, make decisions, provide feedback on what's happened, analyze it, and make autonomous decisions where a human doesn't have to be involved. And that type of capability requires a more balanced compute approach. It needs the ability to control and make decisions. It needs the ability to have heavy-duty compute capabilities, and it requires the ability to move data and information both quickly and efficiently across different parts of the system to ensure that you don't get slowed down or bogged down with bottlenecks. This more balanced approach for agentic solutions requires a combination of CPUs, GPUs, and high-performance networking. And the data center of the future is going to absolutely require that full combination of capabilities to deliver what our customers and what our entire ecosystem really needs for these agentic solutions. Yep. I think we got a slight slide problem. Hold on one second, I'm sorry. All right, well, we're gonna go on an audible. We lost a slide or two here, but let me talk through a couple things. So let me go back to where we were here before we go into sovereign. I think one of the key points that I wanted to highlight in the next piece here is that AMD is uniquely positioned in the market to deliver world-class agentic solutions. AMD is the only company in the industry that offers a full portfolio of hardware components, software support, and partnership within the ecosystem that is really ideal for the agentic era. So if you think about AMD, we have our EPYC CPUs and Instinct CPUs in the data center. And we have our Ryzen AI Halo mobile products, which are ideal from a development perspective. We have CPUs, GPUs, embedded solutions, and networking products, all of which that hardware can be deployed in the cloud or on-prem, and it's all supported and encompassed by what we call our ROCm software suite. We have our ROCm ecosystem, which is our software suite for AI development and for the ecosystem. It is a set of capabilities that we have dramatically matured over the last couple years. In addition, we also have what we call our AMD Enterprise AI Reference Architecture. And this is a set of tools and capabilities such as what we refer to as AIMs, our AMD Inference Microservices and Blueprints, that really allow our customers to deliver turnkey solutions for AI. So across our CPUs, our GPUs, our networking products, our software ecosystem with ROCm and our Enterprise AI Reference Architecture, we're really delivering a comprehensive solution to the market for these enterprise AI solutions. And then building on top of that, we have built out a very, very strong coalition and partner ecosystem with literally hundreds of partners across hardware vendors, CSPs, and ISVs, which we have qualified and certified to make sure that we've got a full stack solution top to bottom. All of that said, it's all built around a really critical foundational assumption and strategy around an open ecosystem, delivering flexibility and choice to our customers, ensuring that our customers have the ability to secure and protect their data, and the flexibility to deploy the solutions that they need where they want, how they want. Again, whether it be in the cloud, on-prem, or in a sovereign solution. So you take all these pieces, the foundational pieces of the portfolio, the open ecosystem, and that partnership. This really is critical to enabling our enterprise AI strategy for these types of solutions, but it's also very, very critical and foundational in terms of enabling our sovereign solutions, which is what Scott's going to talk about. So with that, I'll hand it over to Scott, and we'll talk a little bit more about our sovereign approach.
Thanks, Matt. And you'll get a chance to hear from Matt a little bit later on with more. Seems like we had a little slide fiasco. Did you have the clicker? Thanks. So again, Matt talked a little bit about some of the challenges with getting enterprise AI to run and the mandates of that, and basically AI anywhere. Then one of the layers of that is to actually have sovereign controlled AI, something that, whether it's a nation or whether it's a company, the sovereignty is a really important thing that we want to think about. It's the key to having, it's a key to your destiny versus being locked in. And we wanted to talk a little bit about some of the mandates with that. So a few things we wanted to kind of cover today. One is sovereignty is going to benefit greatly from choice, not lock-in. There's two different paths that you can take for building these big infrastructures today. One is you follow a very defined turnkey approach where everything comes prepackaged, ready to go. That's one way. And there's benefits to that in the fact that it may be a little bit easier to get started. But the downside, the long-term downside of that is you're locked in on a single path that you have no control over. So if governments change desires on what technology might become available, or if a certain type of software stops being available, you're kind of stuck with the path that you're on. What we're trying to do at AMD is build an open software approach where we turn over the building blocks, but allows our customers and our partners to go build out on top of those building blocks those things that they're going to own, that they own themselves. I think that's a really big difference in what we're seeing out in the marketplace today, where again, it's more about that, let me own everything in the stack, from the data center components to the scheduling software to the hardware itself. I think that short term, that may seem like a very easy button that you can push, but long term is going to lead to a lot of lock-in. The next thing we want to just talk about is the sovereign AI or sovereign factory. It's a lot more than just a data center, okay? We can build out these very big data centers and do it at scale. That's part of what we're going to see here. But the other thing is creating that path for users, whether it's France or whether it's Germany, or whether it's even US research, to own their destiny, to own what they're doing with their data. That's a big part of this. The other part of a sovereign AI factory is around the outreach and the engagement. The people that are going to run this gear are not going to use it. The people that are going to run this gear are the researchers, the corporations that are going to find ways to apply this stuff. This gear is so unique to operate. The power constraints are quite difficult. The networking requirements are quite difficult. It's very different than the IT that our customers even our elite customers are used to. So having access to sovereign AI capabilities that they can take advantage of, feel comfortable putting their data into, is kind of a must. But how we outreach to them, how we help them figure out how to apply these AI tools, that's a big part of what these factories are all about. And the last thing, and the reason we're here doing this today with RGS, with Rancher, is that partnership is the way that this is going to come together. This is not going to be one company building out this entire vision. It's going to be lots of companies working together to bring the networking assets, the software assets, the hardware assets, and then the users bringing the data. That's how you're going to see real value with this thing. So those are some of the kind of tenets. Some things I wanted to stress to you is a truly open ecosystem is the way to go, not some kind of shallow open source polish on top of a closed or proprietary core. I think that's something we're really going to focus on making sure we're doing. This has got to be aimed at helping startups all the way to enterprises, really large companies. For these to be successful, we as a community need to be working not only to set this stuff up, but then to outreach to the users that we're going to bring to make these things actually usable. A big part of these sovereign success is going to be finding the users to put on top of these systems to actually make use of them. Because people are a lot of money on these. To not be able to showcase what we're doing with it, have them fully used is a big part of it. The next one I want to just talk on really, really quickly is AI for science. A lot of these sovereign solutions are likely to land on top of traditional HPC locations, universities, public sector research sites like Oak Ridge here in the United States, or Genci in France, or CSC in Finland, places like this. We want to make sure that the compute and the software are prepared for the workloads that not only the enterprises are going to need to do AI, so that we want to be able to do AI for science on top of those things. These solutions that I'm going to talk about in a second that are being built right now, they're going to be like the foundation for how we do research in the future. It's not about a CPU cluster. It's not about a GPU cluster. It's not about quantum. It's about how all these things are going to coexist to give researchers a brand new way to go about doing research. So we'll talk more about that one a little bit. And then the last thing I'll mention is scale is definitely a big part of it. I mentioned it's not just the data center, but being able to scale from 20,000 users to 100,000 users, that's really what this is all about. And we've got to design for that up front as we get started. Okay? So let me keep on going just so we can leave time. I think maybe it just got set. So people often ask me, like, where are we at with all these sovereign announcements? Is it really happening? And I'm really happy to say, yes, it's really happening today. We've got a couple of examples here in the United States with Lux and with Discovery. I'm going to go into more details on those in a moment. But again, these are supercomputer US AI factories that are going in, all designed to be sovereign. Now, the beautiful thing for those of you that are based in the US is it's going to give our researchers access to a tremendous amount of capability. It's going to blend, again, quantum. It's going to blend AI. It's going to blend traditional simulation in HPC as well as agentic all into a single system, which is a beautiful thing. If you're outside the US, these same exact deployments are going to help us build the foundation that anyone around the world can then take and customize for their own use. So it's kind of got a dual purpose. In France, we've got LS Rico. That's going to be Europe's second largest or second exascale system, but it's one of their first AI factories that are going in. That's going to be powered by the brand new MI430 GPU. Lisa will talk about that tomorrow quite a bit in her keynote. So I'm really excited about that. That MI430 system, that's going to power Alice Rico, as well as the HLRS Herder, which is in Germany. That system is designed to be the intersection point between real powerful AI and HPC. It does both AI really well, but it also has FP64 double precision capabilities. And we've got another example at Cambridge University doing a lot of the same thing for the UK. So again, we're actually starting to see this stuff built right now. One of the ones that's actually being installed right now is part of the Genesis mission. Are people familiar with Genesis mission? There we go. We have a few of you. So Genesis was announced not too long ago, but it's part of the Department of Energy. And the idea behind it is they really want to transform, using AI, using this next generation workflow, they want to find a way to double productivity of traditional research. They want to mobilize all of the national labs to interconnect them. So again, in the future, what you're going to have is you're going to have the world's fastest supercomputers interconnected and working closely with brand new cutting edge AI capabilities, talking to and controlling the workflow going into a quantum system, all being aided by helping researchers see, understand, deploy agentic as part of their research workflow. So agents are out there helping explore these problems at a much faster rate than the individual researcher can. So that's what Genesis is all about. We've got our very first system of Genesis being installed right now. In fact, today in Washington, D.C., they're having an event for Genesis, and they're going to unveil Lux. Lux is that first instantiation of Genesis, and it is it's at the very beginning of it. We're actually installing. We've got the majority of the racks in place. It's built on our MI355 today, but in the future, it's going to grow to be much, much more. But we're talking about $1 billion investment from the U.S. government to make this into a reality. It's going to have global reach. We've already had other users from around the world, like Japan, coming in, asking how they take part of this. In addition to like research, traditional research, universities, researchers, we're also seeing over 700 proposals. I don't know what the final number is, but over 700 proposals from corporations that want to find a way to use this new capability. Again, bringing together HPC, AI, quantum, all together. And then again, the thing for me that I'm really excited about is it's going to be the foundation of an AI sovereign stack that the US has, but the same approaches that we use with the same core building blocks are going to be what we use in France, what we use in Germany, what we use all over the world to build exactly the same kind of thing. Now, I mentioned we're not going to do this on our own. This is a partnership, and one of our partners in building this out is Rancher Government Solutions. So I'm going to bring Ryan on up. He's going to talk a little bit more about the role they play in building all this out. So thank you.
Thanks, Scott.
Oh, yeah, good.
Okay.
Scott was mentioning about the core building blocks, about how this sort of epic transformation is going to unfold. It's worthwhile to ask, well, what are some of those building blocks? And one of them is so interesting, at its core, is the Kubernetes orchestration layer. It's so interesting is, when Kubernetes was first developed, and certainly when I first started using it, it was not remotely built with GPUs in mind. And yet, if we fast forward to where we are sitting today, it is an essential part of everything that we've been talking about today, and will continue to serve a ever increasingly important role in both sovereign AI stacks as well as really any sort of AI deployment. And the important thing to ask ourselves is, well, why is that? What makes that so unique? And a couple of the key tenets are highlighted there. Increasingly, if you think about the complexity of deploying out any of the ever-evolving models that we're seeing in the market, one of the core things that immediately comes to any customer that's looking to deploy and manage those types of workloads is, how do you segregate them? Whether you're running in a completely commercial setting or it's a sovereign setting, all end users are going to have some level of requirement in terms of monitoring those models and making sure that they are segmented from other parts of the business or other model environments that they may be running in parallel. A core component of that is at the orchestration layer. Second, right, when you think about how quickly you're seeing the pace of hardware development, and we were talking about this in preparation for the discussion today, about how that cycle time has gone from 5 years to 3 years. Now almost we're talking about looking at updates almost every year, increasingly figuring out how to break out your model workflows from hardware you've already have sitting on the shelf for several years to new chipsets that you've just deployed. The third part, and we'll certainly get into this a little bit more when we talk about what are the core components of sovereignty itself, is when you're actually observing the model. Not just determining its efficiency, but also determining how it's performing. One of the core tenets, right, of sovereign workloads is understanding or making sure that they are compliant with whatever the core use case may be. And third or fourth, what is probably the most interesting thing that we see from some of our customers to date that are already running workloads and are going to be moving even further into a sovereign framework, is the ability to manage this across any sort of heterogeneous environment. This, as sort of a former developer myself, this is something that continues to blow me away, that we at this stage in time can run that. We have this capability with our customers because it's a game changer, not just for what Scott was talking about with the national labs, but really with any sort of hybrid or on-prem deployment that we're seeing with our customers. It's interesting in technology. I think we all sort of seek to live in the most interesting times. And certainly in my career, I've seen a couple of cycles, but yet I think it is fair to say, and perhaps the word unprecedented is overused to lack its meaning at this point, but it is fair to say that we live in unprecedented times, right? And the question that we as a team debate, and we have often discussions with both government customers as well as those that are perhaps in a critical infrastructures that are looking for equivalent security and capacity, is, well, why is this happening now? And I think there are three things for us to consider, and we can talk about this at the end of the discussion with a little bit more. Is first is what Scott and Matt were talking about up front, is that we are now entering to an era where we have seen sort of the shift from moving out of pilot phase into full production deployments. The second we start debating efficiencies and token counting and setting queues for which end users or which requests can make their way into the compute environment, that is a very clear signal that we have moved out of experimentation and are trying to figure out what it looks like to go into full production. And we would be remiss if we didn't think or take a moment to reflect how fast that has occurred in just the last few years. Some end users may just have purchased and gained access to their compute platforms just within the last year and are already jumping into determining the path to efficiency for specific applications or use cases. That is wild. That is something that has not happened before. All end users have had more time to determine this and figure out, right, the appropriate workflows. Now we're figuring not only the architecture, the policy requirements, but also how this all works. Second is sovereign is now a popular term. You know, we at Rancher take a particular sense of pride because we like to say we were sovereign before anyone called themselves sovereign. So that's not trademarked, but it's something that we should consider doing. I'll write that down as a note. But the question is, well, why does this matter now? I think especially as someone that lives in Washington, even just a few months ago, sovereignty was very much in the concept of what you would consider in the think tank world, a policy debate really discussed at a geopolitical level. And that is very true. That is something that is still discussed today, and anyone that is following most recent model releases is obviously tracking this. But that has evolved very quickly into not just what are capabilities at the nation-state level and then the requisite investment driving those capabilities, but furthermore, what does it truly mean for control over the entire tech stack? Not just from the open models or closed models that are being used, but equally to every component of that architecture is what we've been talking about that gives end users not just the control, but the ability to customize and meet specific requirements for different end users. This is something that has evolved rapidly, and from a directionality perspective, it's not going to abate. If you look at just if you've talked to any of the vendors out in the exhibit today, you'll know that the amount of new offerings coming in is only accelerating. And so as a result, having an architecture that's very flexible to move around is going to become the norm. It moves us into a very unique environment where it's best of breed constantly being evaluated as opposed to very static architectures. And third, and this is something that's certainly in the public sector, I would argue is perhaps a leader in some ways, is when we look at capacity build out, you certainly have on the exascale supercomputers, that's one end of the spectrum. On the other, what you're also seeing is that given build-out timelines and different requirements, a diverse array of edge to near edge deployment offerings, which also challenge how these stacks are built. Again, this is all occurring in parallel, which then says, well, how do we have a flexible architecture that allows us to address each one of these challenges and pivot or grow up with the AI market? So as I said, we have been built as sovereign before it was cool, and our core offering that we have been servicing the U.S. government and allied partners for just within modernizing their current software stacks is what we refer to as Carbide. Right? At the heart of our Carbide platform is our Kubernetes engine, RK2. By show of hands, users, people have experienced it. Oh, there we go. Very good. Over the course of our company's life cycle and in concert with our parent company, SUSE, right, we have built this and evolved this into a comprehensive platform for modernizing end users' infrastructure and making not only their infrastructure container ready, but flexible for any type of workload that they want to run, both at the application level as well as being flexible at the hardware level. The unique component when you talk about sovereign, and this sometimes gets lost at a high level, but details matter, is all of the unique specific compliance and security requirements that go into not just building that stack, but deploying it and updating it and maintaining it over the course of a life cycle of a program. And so being from DC, you'll see no shortage of acronym soup there at the bottom. And really what that is highlighting is that over the course of the years, we have built the Carbide platform around specific compliance, both with DISA and NIST and being SALSA Level 3. And then within a majority of our customers, for those of you that have worked in public sector, if you're familiar with the term ATO, or Authority to Operate, having specific security agreements or authority to operate in a wide variety of different end user environments. All of that matters because this is table stakes to deploy into any government environment. Equally, and what is so important, and if we have time, it'll be great for Q&A on this, is that one of the things that we have certainly seen a lot in the market, and you're seeing it in most of the sovereign discussion today, and Scott touched on it a little bit, is that historically, this was very much a hardened open government requirement. As you're seeing in the news in the last several weeks, a convergence between government critical infrastructure, more institutions are starting to take this sort of footing, what we would call almost a hardened sovereign footing. And so as a result, the canary in the coal mine here might be is that this sort of architecture becomes table stakes for any type of sovereign deployment, which allows customers to have that level of trust and transparency when they're looking to deploy perhaps their own model, or they want to manage a wide variety of third-party vendors in that stack. Key part on this stack is that it truly enables each one of those core sovereign AI pillars. At its core, data residency and security is obviously essential, which is why you'll see so many customers that are thinking about this running in a hybrid version or an on-prem environment. Second, and this is the part that is core to our being, and something, if you talk to any of the Rancher team, raise your hands back there, or any of the Sousa team, there we go. They will tell you the same thing in greater detail than me, is operational independence. Right? If at its core, if you think about what sovereign means, it's really about control. However that architecture is, or whatever changes you're going to make, or however much flexibility you want at the apps layer or the hardware layer, at the end of the day, end users want control, and they want to make sure that they can inspect whatever models they're running, and they also want to know, right, that their data is not being used, right, to enable someone else's product downstream. So as a result, that first sub-bullet is essential, right? The ability to agnostically deploy applications is so critical, right? And as one of the reasons for us, right, if you see at the top part of the stack there with the manager, one of the things that we have seen very, very recently is the demand to not just seamlessly deploy a fully open and secure stack, but then that every component of that stack, including the applications, whether those be natively developed, in this case in a government agency, or through a third party, that those applications themselves are seamlessly deployed in a declarative state. The reason I call that out, and we can discuss that in greater detail as well, is that you see where this is going, right? If all compliance is natively baked into the software layer, and then equally any of the applications that are being deployed are now seamlessly being deployed in an automated state, what that means is that more and more of that core component of sovereignty is now running at that orchestration layer. And so from an architecture perspective, this becomes, in our view, a foundational element to any discussion with an end user, especially when you're sitting on top of what Scott and Matt were talking through from the hardware side. Lastly, for us, right, compliance becomes the name of the game, not just for regulatory effect, but increasingly with any of the most recent model releases, what we have found is that customers will be able to want to dig into not just the models themselves, but the entire workflow to see how performant they are or if they're staying consistent with whatever policies were put in place. Looking ahead, right, Scott touched on this a little bit, but it's important to come back to because it touches on everything converges down back to that orchestration layer again. If there is a spectrum of workloads from HPC all the way to emergent quantum accelerators, it is still wild to think that these are all now being converged into a single architecture. You know, I think for most of us in this room, these either haven't existed whatsoever or they have existed entirely in their own silos. And to now live in a state where, as Matt was talking about, that these all now converge through ultimately what is going to be a single control plane, it forces all of us here, when we're thinking about what we want out of a sovereign stack or what capability we want to help enable a customer into, all these become core factors because it becomes a single touch point for a wide variety of customers. So as Scott mentioned, certainly with our work with the national labs, they have been at the forefront of converging HPC workloads with GPUs. This is something that is particularly interesting because that core point Scott was mentioning on Lux, for example, right, the central tenet that it underlies that, one of the central tenets underlies that entire project is the ability for a disparate range of researchers to bring their ideas and their workloads into a single compute architecture. That has not historically existed before, and that is something that you will continue to see as a core requirement coming out for any type of compute architecture going forward. On the enterprise side, and this is something that is happening in real time, again, as everything becomes a core component within a configuration file for a workload, increasingly, even the segmentation that you would see in a traditional AI reference architecture, that is going away. That classic, I run three environments, train, test, and split, or test as we would call it, that's going to go away. That's being forced even more so by some of the companies we were talking to here today, where if you're going to have continuous refinement, this sort of legacy way of how we even think about building and deploying and tuning the models becomes somewhat antiquated quickly, and it's all just a policy condition that state within the configuration file. Equally for us, right, and we were talking a little bit about this beforehand, taking this entire stack and moving it into a completely air-gapped or separated environment that may be running on a single GPU or certainly a lower number of GPUs. This is an area where we, personally on our side, in the public sector, we see this as far and away one of the core areas of innovation across the public sector, both in the military and in civilian use cases. And it forces us to think about what are the core conditions within that stack that drive all those sovereign requirements and shrinking them down so it can go all the way down to something that is man-portable. And lastly, on this spectrum, the same discussion that we were having with HPC applies now on quantum workloads, where you're taking that same control plane and you're trying to optimize both for your quantum workload, then also into your GPU accelerators. So with all that to be said, and in summary, what was old has become new again, and at the core of everything we're talking about on the sovereignty side, a core component of that, right, is what is natively built into that orchestration layer. And we take a lot of pride in being able to work with AMD and bringing this to the market. And with that, I'll turn it back over to Matt or Scott.
Well, how much time do we have left? How much time?
We have 6 minutes.
So we have 6 minutes. So I know there's some people that want to ask some really difficult questions of Ryan, or easy questions of me, one of the two. So you got a question? All right, perfect. If you'll tell me what it is, I'll repeat it so everybody can hear it.
I can project because I've done research in 3 universities over my career. I've been studying AI since I was 14
Yeah.
digress, but the presentation was so well done, there weren't any technical questions.
Well, good to hear. So one of the things that's really important for me is, again, AI has gotten a relatively bad rap as of late for two things. One is taking people's jobs. That's a concern. The other is the power consumption needed to run it. So it's really kind of gotten a little bit negative. We are really hopeful that by giving this focus on AI for science, we can really show what we're able to do to accelerate companies' ability to innovate, accelerate research, things like that. There is real benefit to that. I would imagine back in the early 2000s, people may have had the same kind of complaints about HPC, but I don't think anyone complains when we get a better idea of like where that hurricane is going to head, or if tornadoes are likely, things like that. We've got to show the public that this technology, while it can be used for crazy things, like on the internet and memes of things, it also has a really fantastic upside. And investment in this area is what is going to keep us from falling behind other economies that are investing in this stuff. So I think that's one thing. Any other thoughts on jobs and creation? Anything you've seen from what they're doing with Genesis that's key there?
I think certainly so the classic adage of long to prepare and short to enjoy applies in this case. If you think about most classic AI or ML workloads, so much of the task was either in the infrastructure preparation or the data preparation or deployment management, and very little was on the actual experimentation. Not for a lack of effort or a lack of want, but because those were the sheer limits of engineering that existed, particularly when you start talking about additional security requirements, compute limitations, or if you're forward deployed. Add in any complexity, things go down even slower. And the part that, to be bullish on it, the part that is so compelling is by accelerating some of the infrastructure deployment and compliance, it allows for a lot of what people were originally intending or wanting to explore, which is a lot of the experimentation with model development and implementation. Yeah. And so on our end, it's been interesting, right? You have not necessarily a removal, but essentially almost a reshifting of less on focused on the how and much more on the what once that infrastructure is in place.
Yeah, thanks for the question, May. That was a good one. I saw his hand first, Mike, if that's okay. Yes, sir.
AMD's been pretty good about leading with like totally open source drivers, but it kind of still stops at the microcode where that's still not that's still wrong, the binary law basically. Any plans to go put it even further down the stack into the microcode?
Yeah.
Auditing and modification?
Yeah, I think that's part of what's got to happen. I think again, this stuff is so. Oh, thank you. Yes, I'm glad you said that. So he said that a lot of the work that AMD is doing right now is basically stops at the microcode level. Is there any work or plans to go beyond that for microservices, things like that? What was the other part of the? Just for the open source stack, how far out can we extend that? It's kind of the concept of the question. So again, this stuff is all happening so quickly. Again, you see two paths in the industry. One path where it's I want to control everything, own everything. There is an easy factor that helps you get started down that path. The downside of that is once you're on that highway, there's not very many exits to that highway, and the view doesn't change a whole lot either. So what we're trying to do our best to do is provide the foundational open bits that others like Rancher can plug into and create on top of that. So I think we'd be open to going as deep into that as we can, as long as other people are providing their bit of it to, again, we're providing the foundation, they're going to build the building kind of idea. I hope that helped. We probably have one more question. Yeah, we have one more minute. Michael, yeah.
This is for Ray. The elephant in the room is obviously the growing divide between the three folks down the street who are having fixed weight, lab models, and the open source models. In your discussion with your customers, are you seeing a real reluctance to keep sending their data and their, all of the information they have into their systems?
Yeah,
Repeat the question too.
Yeah, so the question, and Mike, correct me if I don't do justice by it, is from customers that are operating with secure workloads, is there a reticence to leverage, particularly in a production setting, frontier models that are closed sourced relative to an open weight model that allows them to essentially control any of the training weights they have in their data. Is that captures it? Right, and so in a nutshell, right, because no one workload is perhaps the same from a policy perspective, it really, at this point, has been sort of a wide array of use cases, right? So if you look at a lot of business operations cases, there has been no shortage of frontier model deployment within the government. That said, though, this entire stack, right, that we've been talking about, same demand for that, but running it with either their own natively developed applications, right, or in some cases, taking a version of a frontier model and hardening it in a container for their own control and purposes. So when Scott mentions how much it's moving, it is wild to see within a single customer set multiple different architectures for experimentation. Selfishly, the thing that I think one of the things at Rancher that we're particularly excited about is, as we were talking on the national lab side, is starting to see when we have people bring some of their own offerings, VLLM in there, because that, and you're just talking about a sheer scale that I don't have the data to support this statement, but I think it's generally true, is that it would far dwarf anything that we're seeing from a sheer number end user perspective for unique workloads. So the net in the interim, use case dependent, and particularly as you go more sensitive, there's certainly probably a desire for more control.
Team, thank you very much. So we're out of time, but if you had any questions for Matt, Ryan, or myself, the opening, what do you call not ceremony, but whatever the opening, whatever. We're doing the opening right now. We're going to be around. Look for us. We'd be happy to talk a little bit more, but thank you for joining us today. Thank you.